In this video, I'll be analyzing 4 circuits using Kirchhoff's voltage law. Stick around and find out some of the practical problems and some skills you will need to be able to solve these questions. What's up everyone, my name is Joseph and welcome back to STEM in Focus. If you're new to the channel, consider subscribing and hit the bell for notifications so you never miss a video. Before we tackle those questions, first of all, Kirchhoff's voltage law states that the algebraic sum of the potential drops or potential rises across a closed loop is 0. Now this law is based upon certain assumptions. First of all, the magnetic field in the circuit is assumed to be constant. Now in reality, parasitic inductance between the wires causes the magnetic fields to vary, but in low frequency circuits this does not really matter and is quite negligible. For higher frequencies though, the KVL would not hold for all instances and would have to use other methods to analyze our circuits. Now thankfully for the scope of this video, we're analyzing only DC circuits and therefore the KVL will be applicable. Now let's head over onto the computer as we tackle these 4 questions. Okay, so on to the first question. So as we can see here, a voltage source in series with these 3 components. Now these components can be resistors, inductors, capacitors. For now, they're just black boxes to us. Okay, so first of all, we learned that KVL is basically the total sum of the voltage rises and drops in a closed loop, as we have here, is always 0. And so basically, usually what you do is that you write out the equation. So first of all, you start with the main source or like a power source in that loop. So we have our 60 volt, and then you head off with a minus sign. And as we can see here, we have positive 40 volts here. So we write that out as 40 volts and then minus Vx, and now we see that we encounter a minus sign over here. So instead of writing minus, we do it a positive because it's minus minus, that gives us positive, and so that gives us 30, which equals to 0. Okay, and if we do our math, 60 minus 40, that gives us 20, plus 30 minus Vx equals 0. So our Vx equal to 50 volts. So you can bear with me that this is fairly easy. So let's move on to the next question. All right, so for this question, we're supposed to find V2 and then determine I and then find R1 and R3. So as we can see here, we have the polarity of this particular one flipped for this specific question. I had to make some changes after I made the question just so it makes sense. Let's go on to write out our KVL. We can see that 75 is already flipped, and so we have minus 75. And since it was supposed to be minus, but then we meet the minus sign here first, so we get plus 15 plus V2 plus 15 all equals 0. So we have our minus 75 plus 30 plus V2 equals 0. So that gives us minus 45 is equal to minus V2. So our V2 is 45 volts. Okay, so next, so that was our A. Let's go on to B. So B says determine I. Basically I is the current flowing through this whole loop, and so to find I we just basically need, so to find I we use Ohm's law, which is V2 equals I R2. Now we know the value of R2 to be 7, we know the value of V2 to be 45, so this is pretty straightforward. So I equals V2 is 45, R2 is 7. So 7 divided by 45 divided by 7, and so that gives us 6.42 amps. Now on to C. For C, we're supposed to find R1 and R3. So this is our R1, this is our R3. So it's basically the same thing. We use Ohm's law. So V3 is equal to I over R3. So R3 is V3, which is 15 volts, divided by I, which is 6.42 amps. So in the end, we get 2.33 ohms. And since we have the same voltage across both, this is also equal to R1. Okay, so on to the next question. Okay, so question 3 is quite challenging. We've been asked to find the total resistance, total RT, and we're also supposed to find the current flowing through this, and then also we're supposed to find the voltage drops across each component. So first of all, to solve for RT, let's just redraw the circuit by then eliminating the voltage source. So we're going to open that particular part of the circuit, and then we're going to have this resistance here and then this resistance. Okay, so basically we can see that these resistors are all in series, and so that's pretty straightforward. So RT is basically the summation of all these resistors. So you have 22 plus 10, so the total gives us 70.6 ohms. Okay, so now to the current. So now that we found the total resistance, we can basically redraw the circuit as this. So that makes it easy to find the current. We'll just use Ohm's law. So V equals I times R. The current here is 6 volts divided by 70.6. So that gives us 85 milliamps. Now let's move on to C to find the voltage drops across the components. So we're supposed to find the voltage drops. So V1, V2, V4, V3. So we know that V4 is equal to I times R4, which is pretty easy. We already know I, so 85 milliamps times R4 we have here. R4 is 22. So let me just write everything out. So we do all the math on these and we get 2.805 for this. So basically that's question 3. So now let's move on to the last question, which among all these is the most practical. All right, so on to the last question, which is my favorite. We have 8 light bulbs connected in series with a 120 volts voltage source, and each light bulb has an equivalent resistance of 28.125 ohms. So for each of them, they all have that. And so basically we're asked to find the current through the bulbs first of all. So basically to find the current through the bulbs, we know that we're supposed to use is basically going to be Ohm's law. And all we have to do is write out KVL. So we write out 120 and minus, so the first bulb, since it's going to be the same current flowing through here, we can just write I out, and then have 28.125 times 8 equals to 0. Basically it's all these ones summed up, but I'll just rewrite it as a KVL first of all so you can understand it. So it's going to be minus I times 28.125 minus I 28.125 8 times, right? So you get the idea. So basically we pick this and we bring that here. So 120 minus I 28.125 times 8 gives us, so that gives us 225 equals 0. And so when we multiply everything out, we have 120 minus 225I equals 0. So I equals 120 divided by 225. That gives us 0.534 amps. And so now we're being asked to find the voltage drop across each bulb. And since we already have the current, that makes it easy. We can just find, since we already have current, that's also easy. And we know that the resistance for each bulb is the same, so we can just find one and then we'll be done. So we use Ohm's law for this as well. So V equals IR. Let's use that for the first one. And so the voltage drop across one, so V1 voltage drop across I, that's 0.534, and then times R, that's 28.125. So we multiply this out, that gives us 15.02 volts. Thank you for watching. If you found this video helpful, smack the like button, and if you've not subscribed already, please consider subscribing. If you have any questions, please leave a link in the comment section and I'll check those out as well. Thank you for watching, and I'll see you in the next.